Welcome to Module 2, the second part on lathing. In Module 1, we left off talking about the nail flange window, and you should now understand how this window should be flashed. It is not your responsibility or your job to flash the window, but you must be able to recognize the difference between a flashed or an unflashed nail flange window. The procedure shown is a basic flashing for the nail flange window. More complex and alternate flashing methods are certainly acceptable if your company approves it. The most important part for you to understand is to follow the rules that your water-resistant barrier must slip under the sill strip. It is important that you understand the type of window you will be working around and how each style of window will keep water out. The storefront or non-flange window should have a functioning sealant joint around the jambs and sill to keep air and water out. Sealant joints will need to be inspected and replaced at the first signs of wear or aging. The integrated nail flange window revolves around the concept of embedded flashing system. The system has pros and cons. The flanged window, properly rated and installed, seals the flange to the concealed moisture barrier and often requires no maintenance to the building owner. You should understand how they work to keep water out, and then tie your lathing papers or house wraps to make sure they work as promised. Under calm conditions, building exteriors tend to experience very few problems, but winds have an impact on walls and windows of buildings. Wind can create a pressure on the building, and in the case of negative pressure, this can act as a vacuum to draw or suck in the air. This air can in turn carry water into the building. Fortunately, we have layers of finished products that will greatly reduce the impact of this vacuum effect. Materials like taped and sealed drywall on the inside of the stud wall reduce the pressure and air passage. On the outside of the studs, we often have a sheathing to stop the air, and of course we have our cement stucco membrane. Cement stucco is classified by the Energy Code as an air barrier. With multiple layers of finished materials, the pressure is greatly reduced and often stopped. This is why fasteners used to hold the lath to the studs rarely leak. There's no pressure on them. The most likely place to experience this vacuum effect is around the window perimeters. There are many terminations in the materials with potential openings at this location that can allow the air to leak and bring water in. This is why the backer rod and sealant is used in combination with the stucco system as a waterproofing system. The functional sealant joint with a cement plaster keep air and water out. The sealant must bond to your casing bead and the window frame. The designed hourglass shape of the sealant will flex to keep the seal in place, even under pressures from high winds and rain. The nail flange window also experiences wind and vacuum pressures, but they are rarely used on taller buildings as they may not be suitable for more extreme weather or other loads established by the building codes. However, they do work well on most residential and even many light commercial projects. The integral flange is a key factor for a properly rated nail flange window. The flange should be set on a bed of sealant over jamb and sill flashing strips that were installed in a shingle fashion. The integral nail flange works to close off that vacuum leak that was an issue for the non-flanged window frame. The flange serves to block the path of air with or without the stucco membrane. Properly rated and installed nail flange window following SMA caveats will have the sill and jamb strips, the flange embedded in sealant, and this can allow you to run your paper under the sill flashing. This maintains the shingle effect to shed incidental water. As noted, this will keep water out of the system as it is sealed and shingled. This makes it possible to run your stucco to the window frame. Owners like the benefit of no maintenance stucco and no maintenance windows. There are caveats to this allowance. They can be found on the SMA website per the SMA Technical Bulletin. The caveats for abutting stucco to the window frame is limited to several factors, including regional practices, such as the states of Florida and Texas do not recognize this practice. Other caveats are the window must be an integral flanged and code compliant for the location. Does your company allow abutting the stucco to the window? Many contractors prefer the sealant joint around the windows, and you must follow that policy. The final caveat is the architect. Have they detailed a backer rod and sealant? If they have or called it out, it must be installed as detailed. A professional lather will review the windows and the window details. He should notify his supervisor of any concerns he notes. This window had many. First, there was no room for a backer rod and a sealant joint. The lather then put the casing bead in as shown. This left a vulnerable location for leaks. Without any sill or jam flashing and relying on a virtually non-existent sealant joint, this was sure to fail, and it did. The window had no room for a sealant joint and no flashing to tie into. You, the lather, must discuss this with your supervisor and then do as directed. Head flashing can be the simple strip across the top nail flange, or as complex as metal pans with end dams. These type pans come in all shapes and sizes. Some may not have end dams. When metal head flashing is used, it is fairly common to use a casing bead to terminate the stucco above the head flashing, but it is not required. A weep screed is required for stucco on framed walls that sit atop concrete or masonry. The weep screed may be a V-nose or what we call a number 7 style, or may be a standard casing bead with weep holes. Both need a nailing flange that is 3.5 inches tall. The screed is placed at the transitions, and the weep point should be slightly below the top of the concrete. Both screeds work the same and are code compliant. On occasion, the wall may be set back on the concrete foundation. This condition still requires a weep screed, but may need additional or counter flashing. In Florida, it is common to have the first floor masonry and the second floor be framed walls. This also requires a weep screed. Because the thickness of plaster can vary from 7/8 of an inch on the framing to only 1/2 inch on the masonry, this may require specialty trims to handle the stucco at this location. The lather who decides to run the paper down onto the concrete or masonry will likely have an issue with rain. We already acknowledged that incidental water can get behind the stucco. It could weep down the back side of the stucco, and the cement plaster and the concrete are bond to form a dam. The water will seek the path of least resistance, which is often up and under the sill plate and into the building. For those who do not believe this can happen, we have various examples. There is a multi-family condominium with an underground concrete parking structure. The framing above was done without a weep screed. Owners noted wet carpeting along the exterior walls and could not understand where this water was coming from. This should be an example of why we need a weep screed at the base of the framed walls. The building code states that weep screed shall be placed 4 inches above earth and soil. The code also states that stucco weep screed should be placed 2 inches above paving or hard surfaces. It is not uncommon to have the architect draw the detail as shown, clearly allowing for 2 inches of clearance for your weep screed. However, you arrive on site to Lath and you see value engineering has resulted in a few changes. This can happen for a variety of reasons. You no longer have the 2 inches required, but for whatever reason, this now becomes your company's problem. You do not have the 2 inches, so you cannot be code compliant. And it is unlikely you're going to get the concrete removed. There are options that could be considered to meet the intent of the code. This flashing is one example. This is another example that has been used successfully around the United States. These are code alternates meant to meet the intent of the code. They should be approved by the local building department before you implement them. Before you start hanging and attaching your trims, you should note that it is your responsibility to ensure the grounds meet properly. This may require different thicknesses of grounds in various locations. Trim accessories should be neatly mitered and well secured to framing members. A good rule to remember is that trim should not move as the plaster rods or darbies the wall. There are 2 common methods used to form corners with casing beads. One is the basic butt joint, the other is the mitered butt joint. Both can come apart at the corners as they are not connected. There is another option experienced lathers have used for decades. This is what is known as the folded corner. This may look like an ordinary butt joint, but it has a continuous nose that helps to keep the corner square and tied together. This process is easily done with your tin snips. The first step is to establish the location of the first cut. This is taking the edge of the corner and then adding the thickness of cement plaster, in this case 7/8 of an inch. You cut the flange along the red dotted line, but not the green line. Then cut out approximately the same 7/8 inch out in each direction. You then remove this section of the flange. You now have a casing bead with a section of the flange missing. You now cut along the green line, but do not cut the lip. The casing is now folded as shown. This creates a square corner. The result is a square corner with a continuous metal nose that will be square and not come apart. We now know how to apply our paper in a shingle fashion to shed water. But how is he going to know where to attach the lath? How is he going to know where the studs are? The first row of paper is run across to cover the Weep Screed flange, and then the lather marks the stud locations on the paper. The lather has temporarily hung the wire with a few nails. Now he can simply follow his lumber crayon line or the line of fasteners up the wall. You should be able to tell if you're hitting studs or missing them. This is a feel, and you as a professional lather shall develop that feel. It is allowed to place the occasional fastener or staple between the studs to help lay lath down, but it is not okay to attach lath to only the sheathing or to be excessive about fasteners between the studs. This can get your company in trouble. Lath has a memory. This means it will want to return to its manufactured shape. This also explains why the occasional fastener between framing is allowed. It is important that lath does not protrude beyond the grounds. Inside angles are often raked. This is a term we use to take the memory out of the lath. Care must be taken as to not to cut and compromise the concealed barrier. Another and better technique is to raking the lath is to use the side of your hatchet. This also takes the memory out of the lath so the lath will lay flat. The same is true for interior angles. The preferred raking technique is to push the lath in with the top of your lathing hatchet. Lath can be attached to the wall directly from the rolls or sheets. Many times, it will be better to pre-measure and cut the lath to fit a particular area. Lathing shears can make cutting much faster when done on flat surfaces. This can allow a more manageable piece to be applied. In this case, the lather needed what is called a ripper piece. Note the lather is looking down the stud wall for the stud line. He then attaches the lath 6 to 7 inches on center along the studs. The code requires lath to be applied with the long dimension at right angles to the framing supports. This means the lath in rolls or sheets should be applied as shown. The lath must also be lapped by no less than 1 inch for metal lath and 2 inches for woven or welded wires. However, there are situations where this rule can be altered. For example, between closely set windows, it would require a ton of tiny pieces and may serve no benefit to run the lath horizontal. The SMA supports the lath at vertical runs between the windows if the spacing between the windows does not exceed 12 inches. The other location the SMA recognizes is the gable or roof slopes. It is common to run the first run of lath along the slope of the roof or the gable line. This has been done for decades with no issues. This is an acceptable practice if the slope or angle of the lath will be less than 45 degrees. We covered the importance of backing for vertical control joints in Module 1. Spacing should be done per the architect's drawing. Spacing is a design decision and not yours. In general, vertical control joints should run through the horizontals. This allows water to flow more freely. In wet regions, sealing the intersection is strongly advised. These are the 4 common entry points for water. Sealing the joints prior to plastering is also advised. This is what we call back sealing the joints. It keeps it protected from harmful ultraviolet light and should last the life of the structure. Daubs on the outside of the sealant joint will only last a year or 2. Reveals are similar. They should have verticals run through the horizontals. It is also important to fully lap the flange of the reveal with your lath. The reveal flange will want to twist as the building starts to settle. This can result in cracking if the lath is not covering the flange fully. Of course, the lath must be attached to framing members as well. Backsealing of reveals is also recommended in wet regions or areas. This is done by strategically placing daubs of sealant at intersections that could allow water entry. We should think about the path of the water. As it travels down slowly, it can weep out at certain locations. Sealing the top of the reveal seems to make no sense, as this is an exit point for water. Best practices would dictate to seal only the underside where the water could enter and leave the top open to allow water to escape. For walls exposed to significant or frequent rainfall, the SMA recommends sealant around larger penetrations in the concealed barrier, such as light boxes. The practice of sealing the fastener heads used to hold the lath seems like a good idea and certainly could do no harm. However, we have noticed that this creates a thinner scratch coat, as noted by the lighter areas on this cured scratch coat. The result after the brown coat is applied is a clear and sharp score line in the plaster membrane. This is along the stud line because you're required to attach your lath to the studs. This is where the stress loads will most likely impact the plaster. The result is this can lead to hairline cracking along the stud lines. It's not uncommon for the SMA to investigate stucco experiencing consistent vertical cracking every 16 inches, only to find out that sealant was applied to the fastener heads. The fasteners will seal to the wood or metal framing, and there is no need for additional sealant. In fact, the SMA recommends against sealing the fasteners along the studs. You've walked the project, the backing and flashing are in place, and you've cleared any concerns with the supervisor. You're ready to lath. There's one more issue you should probably be looking at, and that would be the wood-based sheathing. We know we're required to put 2 layers of vapor-permeable house wrap, asphaltic paper, felt, or any combination over wood-based sheathings. These layers will keep bulk water out, but they allow moisture as a vapor to pass through. We know that wood can swell slightly when the wet plaster is applied to these vapor-permeable layers. This is why the plaster industry and the wood industry, the APA, both recommend that wood-based sheathing that's to receive stucco shall have a gap at edges and ends of no less than 1/8 inch to allow for this slight expansion. This gap is proven to help reduce cracking in newly applied stucco. Now you have applied your Weep Screed encasing and you're working way up the wall, lapping your paper a minimum 2 inches horizontally and 6 inches vertically. As you apply your house wrap, felt, or building paper, it shall be in a shingle fashion and integrated in that same shingle fashion with all flashings and trims. The hammer tacker used to attach the paper only has 1/4 inch long staples. They pose no threat to water intrusion. They also have limited holding power. Professional lathers will only hang enough paper that they know they can cover with lath the same day to ensure the paper will remain in place overnight. As noted before, you can measure and cut the lath to fit a particular location. You can also apply the lath to overlap and cut out the excess. This is when the tin snips that you have come in handy. They can snip around an opening to ensure the lath is a good tight fit to the casing bead, or even around an arched window opening. Lath must be lapped to minimize cracking. Horizontal laps should be no less than 2 inches of overlap. Vertical laps should be extended to the next stud. In general, it's best to think of a 16-inch overlap. Corner beads or aids are used to provide grounds, straight corners, and reinforce corners from impact and damage. They may be rounded, square, and come in many styles. They must be installed straight. This may require the use of string lines for taller or longer runs. They must be secured to framing or the lath so as not to move during the plaster's application and leveling of the plaster. The type of corner bead or aid selected should be selected by the region of the country and finish coat to be applied. The installer should be aware of regional practices and notify the owner if the product could be problematic. Basic corners include wire nose corner aid, PVC nose aid, expanded metal nose aid, and 100% PVC corners. Selecting the type of corner is very important. Wire nose corner aid is popular and a great product for stucco. However, when an acrylic finish coat is applied over a metal or wire nose in a wet or humid region of the country, this can lead to rusting of the corners. PVC nose corners are a better selection for these projects. Conversely, if a cement finish coat is applied over a PVC nose, it will stick but not bond permanently to that plastic nose. These corners would have been better with a wire nose aid. These pictures are common and found around the United States. No corner is right for all projects or region of the country. An example of regional practices for corners is Florida. The nose is typically left exposed, and considering the environment, wet and humid, using an exposed PVC nose is a pretty good idea. The cement is bonded to the cement base coat and not the nose of the corner aid. Californians would not do this, but they also do not have the Florida weather concerns. Painting of stucco is also common in Florida. Plasterers try to keep the cement off of the nose of the corner so it can be painted. This is an acceptable regional practice and rather unique to the Southeast. Parapets. They are common in stucco buildings, and designers often do not want that metal cap. The SMA always recommends a metal cap as the best assurance against leaks. The cap should cover the stucco a minimum of 2 inches and may need to be extended further in high wind and rain locations. This is not your decision. However, there are the times the designer will win out and the parapet will be directed to be covered in stucco. The following is the best practice when that decision is made and you're directed to cover the parapet in stucco. Your papers must run up the wall and under the peel and stick cap flashing. This must have a 2-inch overlap. Your lath is wrapped over the top of the parapet. Fasteners are applied to the sides and only the sides. No penetration should be made along the top of the parapet. This is why the SMA states parapets should not exceed 8 inches in width when done with stucco. This allows for the lath to be drawn tight across the top. Corners are then applied to make sure the cement will slope slightly to the roof. Do not nail the corners, only wire tie them to secure them to the lath. The parapet wall is now plastered. We make sure it slopes to the roof. A base and mesh is applied over the brown coat, then a primer and finish coat over that lamina. An elastomeric coating is an optional upgrade. Because the parapet has no penetrations across the top, this will not leak. While a metal cap is always preferred, this assembly has proven to work in even wet environments. As we finish up on Module 2, you should now know masonry and concrete substrates will require a lath if the cement plaster will be over 5/8 of an inch thick, but the SMA generally does not recommend paper, felts, or house wraps. Framed walls are protected from moisture intrusion by the cement membrane, but we must plan for incidental or small amounts of water to pass that cement membrane. The paper, felt, or house wraps to be installed must be in a shingle fashion and integrated in that same shingle fashion with all flashings and trims. We must provide a weep at the base of the framed walls, even if that wall is well above ground level. There are 2 primary items for lathers to verify before you start lathing: backing and flashing. Backing is the framing support and critical on vertical reveals and joints. Horizontal joints and reveals may be attached to standard stud spacing, but verticals may require extra framing. Flashing is critical to keep water out. A lack of adequate flashing may result in water leaks. When a sealant joint is required, the design gap should be between 1/4 and 3/4 of an inch wide, unless otherwise directed. Non-flange windows should always have a casing bead and room for the sealant joint discussed. Nail flange windows should be flashed and may have stucco abut the window frame if allowed. Your paper, felt, or house wrap should be lapped a minimum 2 inches horizontally and 6 inches vertically. Larger overlaps are encouraged. Your lath should be lapped 2 inches horizontally and vertical laps should extend to the next stud. Attaching the lath. Attach the lath to the studs not to exceed 7 inches on center along the stud. The fastener must penetrate the stud a minimum 3/4 of an inch. 1 inch is better. Corner beads are very regional, and the nose of the bead should be selected on the region's weather and finish coats that will be applied. Parapets that require stucco over the top should have no penetrations along the top. These rules are important to follow. Lathers that ignore the good and best practices noted in these modules often leave work that fails. Most have no idea they've done anything wrong. Your future depends on building owners wanting stucco. Homeowners who encounter failures will talk to other owners, and stucco will then be avoided. On the other hand, If we install stucco to be cost-effective and trouble-free, owners will tell neighbors that stucco is the best cladding, and stucco will grow. Thank you for watching modules 1 and 2 on lathing for exterior plaster, also known as stucco. For those wishing to be recognized as having the knowledge to be a professional lather, you can go to stuccomanufacturersassociation.com and click on the Training tab to take the multiple choice test. These are 50 questions and you must answer 40 correctly to pass. You will then be issued the card verifying you have passed the SMA Lathing class. Module 3 will cover plastering materials with mixing and safety tips. Modules 4 and 5 are about plastering. We cover hand tool work and plaster pump applications. If you want a lath and plastering training verification, you will need to return and watch modules 3, 4, and 5, and then pass another 50 question test. If you decide in advance to take the lath and plastering test, there is a discount. We will also look at other stucco systems like one-coat stucco and continuous insulation. There will also be enhanced techniques for plastering, including base and mesh for crack reduction and tips on smooth trowel plastering. The SMA would like to thank these manufacturers and suppliers of fine lath and stucco products for making these training videos possible.